Red Hat OpenShift is the sponsor for our container platform coverage from OSCON in Austin, Texas. OpenShift reaches across open source communities to collaborate for healthy upstream development. The goal? Ensure the support for features and functionalities that end users require across the overall ecosystem. You can learn more at openshift.com. Hey, it's Alex Williams of the New Stack here at OSCON in Austin, Texas, and we're here right now with Adam Miller and Jim Perrin, both of Red Hat, who are going to talk about kind of this concept of, of really container build pipelines with CentOS and Fedora. Thanks, guys, for joining us.
No problem.
Thank you.
So tell us about what this means. These container build pipelines that you're building for CentOS and Fedora. What is the genesis of this, and where are we now?
So I think one of the ways to start this off is to look at the workflow that we've had in the past with bare metal and with VMs, and that concept is still very much alive despite people shifting to containers. And so one of the things that we're trying to get to is having as dull and uneventful an experience with our distribution as possible. Whether you're using bare metal, whether you're using a VM, or now into that container space, I want that experience to be as similar and as coherent across every platform as possible.
Right.
So for me, it's getting that consistency across all of it, and one of the ways to do that is through container pipeline
It's
build.
always been consistent. Hasn't it?
But you have to
what's
put
the big
work.
deal here?
You have to put work and effort into making it consistent, though. That's where the trouble comes in. That's
so interesting. Actually, in the Fedora space, we're trying to shake it up. We're trying to remove some of the consistency. We're trying to move forward with some of the, so there's the Fedora.net.
What are you shaking up?
So there's the Fedora.next initiative, and what that is that's to try and loosely couple different, layers. There's a concept of the rings, and there's ring 0, which would be the core of the operating system, things that we're used to today, and then we're starting to get to a point where we're defining where the operating system ends and the application begins. And what that's kind of alluding to is this newer idea where those two things don't need to be as tightly coupled in the future. They can be disjoint. They can have a different life cycle and those sorts of things. And what we're working on is a Fedora modularization project. There's also different things going on in the upstream. So XDG app recently got renamed to Flatpak, which allows you to run desktop graphical applications in a sandbox environment in a way that won't require core distribution components to run. They can run across multiple distributions. And then again, for server side and command line space, you have your Docker containers, and there's also Rocket and Run C and all these other things. And what we want to do with the container build pipelines is create an environment for our contributors to build and create content through common build recipes, for lack of a different phrase. So right now for RPMs, we have a way to build RPMs, and those go through a build process, and that build process is reproducible, it's repeatable, it's auditable, and it's consistent, and we can do that same thing with containers, and that's kind of the goal of the build pipeline. Another piece of it is also, once it goes through the build, now you have an artifact. You have an artifact of that build, and you need to do something with it. And generally, the step from a build is to then start to test it and provide quality assurance around it. So we want to create an environment where you can have the build and the test be completely automated. So somebody can come in and say, hey, here's the thing that I made, and they can put it in a Git repository somewhere, and then once they do, it will automatically kind of kick off a series of events. And once the build is completed, that will fire off in Fedora space, we have what's called Fed message. It's our message bus on the back end of everything. Then the QA system will pick up that message and say, hey, there's a new artifact that needs to be tested, run it through the series of tests, and then we have our gated update portal called Bodhi, and then the update can go and kind of graduate through there and become stable. And this kind of workflow for all kinds of artifacts that we've created, we want to allow to be done with containers, and that's kind of the first step we're doing right now. Where we are today, we have in staging in Fedora this entire build pipeline that I just talked about for Docker containers. In the future, we are going to try and enable other types of things. The Flatpak that I talked about earlier for graphical environment applications, we're working on that right now as well. So there's a lot of different things going on in those spaces, and so we want to allow applications that are created by contributors out in the world who want to very rapidly innovate, very rapidly iterate, to be delivered and built in a way that it doesn't necessarily have to be tied to the core of the operating system.
That's where the containers come in.
That's where the containers come in. That's what lets the platform stay stable and the applications run at a faster pace if they desire.
And we take a bit of a different approach. We have the core distribution CI at ci.centos.org that we've been pushing for a while now that lets people test their packages against CentOS. We're building the container pipeline for our distribution into that so you can test your packages, your software against the core OS, whether it's bare metal, whether it's a virtual machine, or whether it's a container, so you can have that consistent environment across the board. And if you just want to focus on only building containers, that's great. We're not going to tell you how to run your application. We want that consistency across all of it. So that's
So this container build pipeline. How do you set that up? How do you manage it? Can you take us a little bit through that?
So on the CentOS process, the way that it works is essentially you would point your Git repository, wherever that is, at our build system. You register through accounts.centos.org. You get your credentials. You plug that in, and then you put a file. Once our build system knows where your repository is, you put a file in your Git repository that's essentially a YAML instruction set that says, this is what I need to build. These are the tests that should be run against this software collection or this package or whatever it happens to be. And from that point on, every time you do a git push, the hash changes, and so our build system will check periodically, pick up and say, oh, the hash has changed, now we need to do this. So right now we're running that on a fairly frequent system, and we're going to be building in hooks to that, so it's a little more, as soon as you hit push, it knows and starts cycling those tests through. The other thing that this allows on our side is for the different projects that we're working with, be it Gluster or RDO or Ceph or any of those, if there are interdependencies between them, because several of these projects build against the same packages, if there's a change that happens to one of those packages, it kicks off the testing for both or for the projects that depend on it. So they will know if we have a change for libvirt, for example. The projects that depend on libvirt will know almost instantaneously if their individual tests have passed against it, or hey, this update breaks this, I need to fix my code in this particular place.
Right. Okay.
So for us, it's more about the operations side, and as a sysadmin or ops mentality, it doesn't necessarily matter if it's container or VM or anything else. It's that the application runs as expected, that all of the tests have passed, or that the tests get updated appropriately, and that from an ops perspective, everything runs as it should. The user shouldn't know or care how it's running, and that's what we're trying to drive to.
What's the parallel then to?
So from the Fedora side, we handle it slightly different in terms of what we expose to the contributor, mostly because we kind of target, I think, a slightly different audience. So currently Fedora contributors, if you want to maintain a package that's inside of the distribution, that is done through a handful of systems that are tightly integrated, I guess loosely coupled. They're tightly integrated in terms of we have a set of tools that allow you to use them from a single entry point.
Loosely coupled, tightly bound, is that the...
Yeah, that's probably a better phrasing for it. Yeah, my vocabulary didn't quite serve me well. So there's a command line tool called fedpackage. It's fedpkg, and that allows you to do a number of things. And that allows you to interface with what we call dist-git, and it's a Git-based repository structure that has a well-defined set of have branches, and the branches correlate to releases of the operating system.
And so then can you correlate the containers to the branches then?
Right. So the way that we do it historically, because since the dawn of the Fedora project, and even before that, Red Hat Linux in the 90s, there was RPMs. That was the build artifact that we distributed, and now we're getting into a world where that's not the only build artifact we distribute. So distgit is now namespaced, and inside of distgit, the RPMs namespace, you have your spec files and your source code and your patches, and then inside of the Docker namespace, you will have a Docker file and potentially a couple of management scripts, because one thing that's very common in Docker files is to put in some kind of like a startup script that will perform some kind of function, and that will be checked into the system, into our Git repository, and that will correlate to specific Fedora releases, and the builds that will fire off from there will use the Fedora base image that correlates to the version that goes with the distgit, and that gets handled through our Koji. It's a build system called Koji. It's our central build system. It creates all of the media, all of the artifacts that we produce. So our cloud images that go up to cloud services like AWS and GCE. It creates our live CDs, our live USB images, all of the QCOW images that are used for virtualization, all those things. So the build will be scheduled through there, and then actually on the back end uses a tool called OSBS. And what OSBS is, it's OpenShift build service. And what that does is that kind of wraps and encapsulates a lot of the functionality that OpenShift provides as a container builder. It's one of the primitives that they use for what's called source to image. If you've at all heard of OpenShift and its source to image, basically you provide source to image with a Git repository and some metadata, and it will do the build and output that for you. Inside of there, we use a tool called Atomic Reactor, and Atomic Reactor does a lot of different things that allow you to automatically promote it to different Docker registries. It also lets you inject alternative sources for content, so we can, in a very secure environment, say, instead of allowing you to pull from public mirrors or from the internet, we can, inside the build route, say we want to use the provided content repository for Fedora, and this is common in a lot of build environments, so that way nobody has a script somewhere in their build that tries to pull something from the internet and inject it into what becomes the resulting artifact that people download. And this kind of goes along with the verifiability and the audit trail and those kinds of things. So what we present is the ability for somebody to do a Fed package checkout or a Fed package clone, and then they will do a Fed package commit, which would then commit to that distgit repository, and they would do a Fed package container build, and that would schedule the container build, and that would kind of handle it from there. So that would then go through Koji, schedule it with OSBS, and in the end result, you would, in the Koji web user interface, as well as the Koji command line, see information about your build, whether it passed or failed, and if it passed, it would tell you where you can then pull it from in the Docker registry that it would end up.
So it seems like a storyline here is about portability, isn't it?
Mm-hmm. Absolutely.
How so?
In a lot of ways, the new container technologies have allowed us to take build artifacts that can be moved to different places, and there are certainly corner cases and things where ABI compatibility becomes an issue. If you go from distro to distro, that is a problem that has come up, and it's something that I think we as a community try to address, and that's something that the new Flatpak project is trying to work on from a
registry integration.
So registry integration is another thing too. And just from the Fedora side, once it lands into a stable repository, we actually plan to do what we call a stable promote. And once it promotes stable, it will then be in the Fedora registry, but it will also be pushed out and synchronized with the Docker Hub publicly.
Sorry if I
No, I was just going to say,
jump
I
in.
was just to allow people to get to the content that way.
One of the things that we want to promote on our side, in addition to that content portability, we're going to build it, we're going to make it easy for users to get it and consume it. but you don't necessarily have to trust us if you don't want to. In addition to publishing that content, we're also publishing the recipe for how to build that. So you can take what we have done and duplicate that work yourself. If you don't want to trust me, or if you don't want to trust Adam, you can take it, you can do it yourself. You've got step-by-step directions for how that happens, and you can then compare the results and say, yes, everything that I got from them is exactly as they say it should be. This builds appropriately. The other aspect of that is it eliminates some of that, well, it works on my machine, you must be doing something wrong kind of side effect that we see, because maybe, he builds on a Thursday and I build on a Friday, and something has changed between those two time frames. So,
and actually the ability to reproduce is kind of a good point to bring up, because in Fedora and in CentOS as well, our systems are actually public in the sense that you can see all of the recipes by which we make them. So Fedora, our infrastructure team uses Ansible. All of our Ansible repositories are public except for the private one that needs to store private credentials and keys and those kinds of things. So those are referenced by variable in the public playbooks, the Ansible playbooks. But everything about how to deploy the infrastructure itself is public and available, and we have documentation of how to do it. And then also the tools that we use are all open source. So the only thing that we do in terms of trying to gate it is just making sure that the build route isn't able to go out and grab random things from the internet that could potentially be harmful. But yeah, the build systems themselves and all of the software is completely open source, and we publish information and recipes of how to recreate it.
Yeah, I guess the question, my last question is where can people go to learn more?
Okay, I'll go first. So Fedora, we have a Kanban board. So Taiga, TAIGA.fedoraproject.org. So the work that's going on in the Fedora release engineering team, which is the team that I'm a part of, we're working on a lot of tools around containers and also Project Atomic, so Atomic Host, which I'll speak to briefly in just a second. So that's a good place to kind of monitor what's going on. RelEng, release engineering. So if you just the Fedora wiki, look up release engineering. We have a lot of information there as well. The Fedora Cloud Special Interest Group. We're kind of focusing on a lot of things in the Project Atomic space, and what's interesting about that is that's actually cross-distro. So Project Atomic is an upstream project based around container technology, as well as a new virtual, it doesn't have to be a virtual machine, but a new container-optimized operating system image that can be virtual or run on bare metal. And both Fedora and CentOS are kind of collaborating and embracing that upstream. Fedora has an Atomic Host, CentOS has an Atomic Host, and we work together to try to align on both tooling and processes around how to produce those, so that anyone who wants to use one or create a derived work from one is able to.
Great.
Yep. So on the CentOS side, we have our documentation, and our process for doing all of this is available on the CentOS wiki. It's wiki.centos.org. And again, to echo the Project Atomic bit, we're building the exact same, or I shouldn't say it's the exact same. We're using the same processes to develop Project Atomic against either the CentOS repository or against the Fedora repository. So if you're familiar with Fedora, you like the way the Fedora libraries are structured, you want to use that, then there's a Fedora Atomic build. If you've got CentOS in your environment and that's what you use and that's what you want to stabilize on, then great. And there's an Atomic build that's based on CentOS that we push out as well. So it's
and just really quick, I think the goal of having both of those is very similar to why the two projects exist. Is one of us, so Fedora is very rapid in terms of the operating system itself. There's a lot of churn there. So if people are interested in the more core components of the operating system, the more late-breaking technology in that realm, Fedora is probably a good space to participate. But for people who want to iterate on kind of like the layered platforms on top of the operating system, where they want the operating system to be very stable and very, I guess, static in nature, such that it doesn't change as rapidly. I mean, you're going to get change, you're going to get innovations, but it comes out in a more, predictable release cadence in terms of long-term life cycle. Then your audience is probably going to go to the CentOS size. But we try to collaborate because in terms of technology, we exist in the same family of technology, and we're working on a lot of things together.
Fedora does a lot of fantastic work on developing the platforms and building the platforms up. And our goal isn't necessarily to work on the platform a lot of that has already been handled and taken care of. Our goal is to allow everybody else who's developing their own software stacks to run and deploy their stacks on the stuff that we've got. So we're more interested in allowing the third parties, the folks that we don't know about, to take our stacks and build for that, to target that as their platform of choice. So it's different sides of the same tooling, and it's in how you approach it. So,
Well, guys, thank you very much for joining us for this conversation. I learned a lot, and I think this is just another example of these new distributed environments that we're seeing, and there's a lot of work to go along the way, so we look forward to keeping in touch.
Great, thank you so much.
Great, thank you.
Thanks for having us.
Red Hat OpenShift is the sponsor for our container platform coverage from OSCON in Austin, Texas. OpenShift reaches across open source communities to collaborate for healthy upstream development. The goal? Ensure the support for features and functionalities that end users require across the overall ecosystem. You can learn more at openshift.com.